So we've been talking about linear equations with variables on both sides. So we're going to continue practicing today, looking at this equation that they have given to us, paying particular attention to both sides of the equal sign and seeing what different strategies we can use to begin solving. So let's go ahead and write it in our notebook so that we have plenty of space. Okay. So the first thing I know is that we need to break up our equation from the left side and the right side, knowing that what we do on the left has to also be done on the right to maintain a balanced and equal equation. So looking at the left side, I see that there is a number directly in front of parentheses, which is this 2. And I know that that means that we need to multiply, right? When something is smushed together, it is a sign of multiplication. And so I also remember that we went over the distributive property where I multiply the 2 with every term inside the parentheses. So I want to just circle really quickly as well to make sure that we see this as a positive 3x and a positive 2, right? We look at the operation sign in front to give us clues as to how we're going to multiply and what sign is going to be on our answer. So 2 times 3x gets us 6x, so let's write that. And then 2 times a positive 2 gets us a positive 4, so we would write that as plus 4. Okay, so now that we have multiplied those out, is there anything else we can combine on the left side? No, there is not. So now we're going to look at the right side to see if there's anything we can combine there. So I see 2x minus 1 plus x. So first off, I'm going to identify what is alike by circling the numbers, including the operation sign in front. So I see two variables that are an x, and then I see a minus 1 without an x, so I know that that is not alike, therefore I cannot combine it. And then, now that we've identified it, 2x plus 1x gives us 3x's, so we can write that below, and then minus 1. Now, can we combine anything else on the right side? No, we cannot, because they are not like terms. One has a variable of x, whereas the other one does not. Therefore, we have combined each side as much as we can. So I know we still need to figure out what x is. So we have so far combined everything on the left and on the right. I'm going to write GEMDAS to the side because I know we have to use our order of operations backwards when solving equations. And so I'm going to focus my eye on adding and subtracting so we can deal with that first. So I see that there's a plus 4 and a minus 1. So what would the inverse operations of adding and subtracting be? Well, I know that the opposite of adding 4 would be taking away 4, and the opposite of taking away 1 would be adding 1. Well, we could do either, but what might be like the easiest or a preferred choice? Well, I actually like doing the opposite of subtraction more because I know that leads to addition. So I'm actually going to get rid of the minus 1 first by adding 1 to both sides. Now keep in mind that again, I am not adding 1 to the 6x because these are not like terms. I can only add 1 to a number that was without a variable, and that would be that 4. So I am left with 6x, and then 4 plus 1 is 5, so 6x plus 5 equals 3x because these ones have canceled. They have equaled 0, so they are gone. Okay, so far so good. Now, I still have two variables, one x on the one side and one x on the other, and so I need to combine those as well using our inverse operations so that I can focus on only one x. And so I could take away the 6x or the 3x, but if I take away 3x, there would be nothing left on the right side. So I'm going to take away the 6x, right? So the opposite of, excuse me, a positive 6x is subtracting 6x. And so these x's have been canceled out, and we are left with 5 equals. And now 3x minus 6x, let's go ahead and write that over to the side because I know we are taking away more x's than what we have. And so if you already know what that is in your head, then you can go ahead and write that down. But I know that we can also rewrite the subtraction problem using keep, change, flip. And then if I look at my tic-tac-toe chart, I see a positive and a negative number being combined. So I know when we have a positive and a negative, we need to subtract. And 6 minus 3 is 3x. 6 is bigger, so therefore it is a negative 3x. So we're going to write that there as well. Alrighty, so I see no more adding, no more subtracting. So now my eye is going to go to what I can multiply and divide since I only have one variable left, right? There's nothing else I need to combine on both sides, and I only see one x, and I know that it's multiplying the -3 times this x, and I know the inverse operation is division. So we're going to divide both sides by the -3 so that we can get x all by itself and figure out what 1x equals. So -3 divided by -3 is 1. So we're left with x equals, I could write -5/3. I could also use bow tie to then change this to a decimal and see what I get. And 3 goes into 20. Oh, add my decimal. 6 times -18 to 0. And that is a repeating number. So I could either write it as -5/3 or x equals -1.6 repeating, and both are correct. Alrighty, so now that we have solved and figured out the answer to our equation, we can double check our work by substituting this number right back in for x to see if we get a true statement. So I'm going to rewrite it below. So 2 parentheses 3x plus 2 equals 2x minus 1 plus x. And actually, I know that I've already distributed this, so actually let's write the simplified version, right? That way we don't have to go back and redistribute and do all these fun things. And now I'm going to substitute everywhere I see an x with the -5/3. And because the decimal is a repeating decimal, so it's going to be a lot more accurate using the fractional representation instead of that repeating decimal representation. All right, so now that I have substituted the x, we can go ahead and follow our order of operations in the normal top to bottom strategy we normally do. And so we don't have any grouping symbols because the numbers in parentheses don't actually have an operation being done to them, and there's no exponents. So now we can multiply and divide. So I see multiplication here and here. So over to the side, let's go ahead and multiply 6 times -5/3, and I know I make that a fraction by putting a 1 underneath. I also know that I multiply straight across to get -30/3, which would be simplified to -10 plus 4, because we didn't do anything with the 4 yet. And then 3/1 times a -5/3, remembering to multiply across once more, gives me a -15/3. And when I simplify, I get a -5. And then bring down the -1. Okay, getting closer and closer. Now I see a -10 plus 4, and since I moved my screen, I can't see my tic-tac-toe chart anymore. But a negative and a positive means that I have to subtract. And so 10 minus 4 is 6, and 10 is bigger, so that is a -6. And now I see a -5 minus 1, but I know I can rewrite -5 minus 1 using KCF, right? Subtraction problems can be rewritten to addition problems. And now that the signs are the same, we can add and keep the sign. So our answer is -6 as well. Whew. So we kind of combined everything we've been talking about with the distributive property, with combining like terms, with our inverse operations, with our multiplying fractions, and our tic-tac-toe chart. Everything has come together, and now we have a -6 on one side and a -6 on the other. Is this a true statement? Are these two numbers equal? Yes, they are. So what does this mean? Well, if we look back up at our answer, it means that we were correct when we solved and got the answer -5/3. And we know that because when we substituted this number in for x, we got a true statement, right? We ended up with a true statement of -6 being equal to -6. So now we know we did it correctly. So in the next problem, we're going to do the same process of combining like terms on the left and the right until we can't anymore. Then we're going to combine like terms on either side of the equal sign until we can't anymore. And then we can solve our equation using the remaining inverse operations and then check our solution using substitution to determine if we did it correctly. Let's try one on your own.